Okay, in this video, we're going to take a look at prime and composite numbers. So make sure you put today's date in the upper right-hand corner of your notes. All right, first things, let's define what a prime number is. A prime number is a whole number greater than 1 whose only factors are 1 and itself. So a prime number is a whole number, so that means not a decimal, not a fraction. Greater than 1 whose only factors are 1 and itself. All right, so let's consider some examples. Two is a prime number. So if you think about it, the only way to multiply to get 2 would be 2 times 1. So 2 and 1 are the only factors. So the only whole numbers you can use to multiply together to get 2. There's no other way to multiply with 2 using whole numbers. Three is also a prime number. The only numbers that can be used to get 3 to multiply are 3 times 1. So they are the only factors. Four is not prime. And we're going to use a different word to describe numbers that aren't prime, but the reason 4 isn't prime is, think about it, you could do 4 times 1, or you could also do 2 times 2, right? So this has more than just 1 and the number itself as factors. Five is a prime number. Because here again, you can only do 5 and 1 to multiply together to get 5. They are the only factors. There are lots more prime numbers, and we'll talk about how we can find those and do a little bit of investigation. But I also wanted to describe a different type of number as well. So numbers that aren't prime, we call composite. So a composite number is a number greater than 1 who has more than just 1 in itself as factors. So a composite number is a number greater than 1 who has more than just 1 in itself as factors. So let's take a look at some examples. We looked at one example already of a number that wasn't prime, and so we know the definition now of that would be a composite number. So the first example is 4. 4 is a composite number. Remember the multiples of 4, or excuse me, the factors of 4 are 4 times 1 or 2 times 2. So there it has more than just 4 and, excuse me, more than the number itself, 4 and 1 as factors. Another example, 6 is a composite number. Here we've got 6 times 1 or 2 times 3. And again, we have more than just number 6 and 1 as factors because you also have 2 times 3. So looking at those numbers, you might be thinking, well, even numbers must always be composite. And that's true except for the number 2, because 2 is an even number, and that one we said was prime. But every other even number is composite. But I don't want you to think that means that odd numbers can't be composite, because think about the number 9. 9 is a composite number. And I'm using that pound symbol as number just as an abbreviation. So the multiples of 9 are 9 times 1, so the number itself times 1, or 3 times 3. So here we have an odd number that also happened to be composite. Another example of a composite odd number would be 63. 63 is a composite number. So we have 1 times 63 as factors, 3 times 21, 7 times 9. Those are the factors of 63, so it shows that you have more than just 1 in the number itself as factors, and that's a definition of a composite number. So you're going to work on identifying prime versus composite numbers, figuring out what are the factors of those numbers. You might have to use your divisibility tests to see if you can divide a number by one of those factors that we've talked about. So let's look at an example. Let's say I gave you a list of numbers and I ask you to identify is it prime. So which numbers are prime? Or composite? So let's give you 3 numbers. Let's say I gave you the number 25, 13, 27. So we want to do, is it prime? We'll put a check mark next to prime. Or is it composite? So again, is this one prime or composite? Prime or composite? All right, so to figure this out, we're going to want to use our calculators and use those rules that we did before. So 25, I know 25 can't be divided by 2, so I know that that's not a factor. So 2 is not a factor. So I know I can do 1 times 25, and I get 25. I know 25 and 3 don't work, so if I divide that, that doesn't work. That number does end in 5, though. So 25 divided by 5, that gives me 5. So the factors of 25 are 1 and 25, and 5 times 5. So that makes it composite, because it has more than just 1 in itself as factors. Let's look at 13. 13 is an odd number, so I can't divide it by 2, right? It gives me a decimal. 13 divided by 3, well, that doesn't work either. How about 13 divided by 4? Nope, that's not working. It doesn't end in 5 or 0, so I can't divide it by 5 or 10. 13 divided by 7, maybe? Nope, that still gives me a weird decimal. 13 divided by 8. Nope. So I'm thinking this one is prime, and if you think about it, the only way to multiply to get 13 is 1 times 13 using whole numbers. For 27, I know 27 divided by 2 won't work. That'll give me a decimal. It's an odd number. But what about 27 divided by 3? Oh, that's 3 times 9. So this one would be composite, because I could do 1 times 27 or 3 times 9. So you're going to look at some numbers and try to figure out if they're prime or composite.